We're good. All right. Program we've all written, right? Does it work? Surely. Yeah, I have dot in my path. I bet I know who doesn't have dot in his path. You have dot in your path?
Dot in my path.
Oh, you don't know. Oh. Oh, well, here, I'll tell you then. That's actually not a bad thing. Because people, you ever notice how sometimes you have to do that, right? Whereas when I do that, it's like that. Well, here's the story. There's an environment variable in your shell called path. When you look at it, you set this up in your bash RC file, okay? That it's a bunch of directories separated by colons. And then your operating system, when it launches an executable, which we'll get to in Lab 7, right? If you specify to the operating system, please look at my path. You can tell the OS, don't look at my path. But if you say, please look at my path, then what it does is it goes through each of these and looks for the executable. So when I type ls, it's going to try to find it in this directory, and then it's going to probably find it in this directory, et cetera, et cetera. Okay? Now, if you have dot in your path, you'll notice the last thing in my path is a dot. That it actually does look at the current directory while doing it. Now, is that exposing yourself to a bug or to something malignant? Yeah, 100%, right? If it's not like if I type ls, it's going to use someone else's ls, right? ls is sitting there in user bin. That's why you don't put dot first in your path. If I put dot first in my path, then this is the first directory that gets checked. And what happens? I cd to your directory, and then I type ls. Now I'm running your ls, potentially. And your ls could say, here, remove all my files. Right? So that's why you don't want dot in the beginning of your path. At the end of your path, it's not quite as bad. It's still an exposure because let's say I just do a typo. Right? Now if I do a typo on the name of now I might be running someone else's code. Right? Is there another reason, Jake? Okay. I didn't know if there's a... So most system administrators will tell you not to put dot in your path, but my life is just too difficult, so that's why dot's at the end of my path. Now you know. I taught you something useful today. Maybe. Okay, let's turn this into a C program. All right, we're done with that. In C, you got to say standard.io.h. And that's, in C++, you included this library by saying C standard.io. In C, they all have to have .h's. So standard.io.h, usually you got to include standardlib.h, which is too bad. And even worse yet, life is so unportable these days. Often you got to include unistud.h. Often you don't, right? Who makes these decisions? Mean people. Mean people make these decisions. Okay, there's no namespace. Yay. And now here, instead of doing that, we're going to use printf. How many of you all have used printf before? Yay. Okay, so printf hello world. Exit 1, return 0, whichever it is. We'll learn what all that means too. We'll deal with this, the implications of this semester as well. Okay, so now we'll call GCC. All right, and we got hello world. Yeah, it's all good. I think in C, comments should be like that, but they put C++ standard comments into the standard long ago. I'm sure C99 is going to allow C++ style comments. I still don't do it in C code. I just don't. I always live under the assumption that you never know when you're going to have to use an operating system from like 1906, 2006, right? Why? I'm at Oak Ridge, right? Those Oak Ridge supercomputers, you think they have the latest and greatest software on them? It's terrible. It's awful, awful software. So, and old. So it's usually good to program to an older standard so that your code can be more portable. That's what I do. Not everyone else does that. In fact, it's actually interesting. In our research group, we're now working with a student or a researcher, a PhD researcher from Oak Ridge, he was actually an undergrad here and a PhD student here, super smart. And he and I have the exact opposite philosophy on software and life. His philosophy is keep everything up to date to the second, read every manual you ever see, and make sure that everything works. And my philosophy is don't ever update anything unless you get told you have to, right? And that way you don't have to read any manuals, right? And your stuff works. So we've had some clashes about that. But fortunately, our research code is split into C++ and Python. And so I can shove him over to Python, and then he doesn't affect me in C++. All right, what am I doing? Types. Okay. Types in C. I'll put that in a comment. There are basically, I'm just going to put this in parentheses because there are more, but there are basically 7 types in C. Okay. We got char. Okay. How many bytes is the char? 1. Okay. Signed or unsigned? Ooh, conflict. I like it. When I write it like this, it's signed. The default is signed. If I want it, I can say signed. If I want it unsigned, I can say unsigned. Okay. Now, what does it mean if I say signed or unsigned? Well, if I say unsigned, like this, my char is going to have a value between 0 and 255. Okay. If I say signed, it'll have a value between negative 128 and 127. Does that make life a pain in the ass at times? Hell yeah. There's no doubt it makes life a pain in the ass at times. But you got to be aware of it. There are a lot of times you got to be aware of it because there are a lot of times you want the memory savings of a byte, but you'd rather have it be unsigned than it be signed. Right? And so there are times you are going to have to pay attention to that in life. It just is what it is. And all of your integer data types, and this is an integer data type, have signed and unsigned. Okay. Short. Anyone ever used a short? Yeah. It's 2 bytes. 2 bytes. 0 to 65 something and something, or negative 32 something, or 33 something to 33 something. It's a surprisingly useful data type at times. It can be signed or unsigned. Okay, what's that? Sure. How big is an integer on your Arduino? I learned that the hard way. That one took me about 2 hours of bug finding before I was like, what the fuck? And then I opened up a manual. It's like, oh, int is 2 bytes. What? What's wrong with you? And then I kind of thought it was kind of fun. Now I know. So a long int is 4 on an Arduino. Okay. Who doesn't know what an Arduino is? Just 1 or 2? It's awesome. It's a microcontroller. It's a little piece of hardware that has a little processor on it. It has an operating system, but not really. It doesn't have a file system or anything like that. And then it's got a bunch of wire ports, and so you can then write programs that will read and write the wire ports. So basically, it's how you do embedded computing, and they're cheap. Whereas Raspberry Pi puts out a microcontroller that's $4, right? But it's got a, how fast is the processor? Do we know? Is it even a gigahertz? No one knows.
I think for the new 5s, they're about 2 gigahertz. But if you get like the Raspberry Pi Zero, it's like half a gigahertz or something.
Yeah, well, this is probably less because those are full blown. Those Raspberry Pis are actually.
Oh, the Pico?
Yeah.
Oh, yeah, I have no idea.
Yeah. The Raspberry Pi. Those are just little single board computers. Those are great. They're fun to play with too, right? They're cheap. You hook them up to a TV, pop an SD card on them. Now you got a nice little Unix that's running really slow, right? And that's fun because it makes you a better programmer when things are really slow. But the microcontroller version of it, they're super cheap. Yeah, they're probably running. They're chunking on probably in the megahertz for a couple hundreds of megahertz.
Yeah.
Is that what it is? And it's got like it's got 256K or meg of memory. I think it might be meg. Is it K? Yeah. Anyway, they're fun. Arduinos are fun. All those little embedded things, they're a lot of fun. And they're very small and cheap and slow, like God intended. Okay, int 4 bytes. Okay, so you got a 4 byte quantity, again, signed or unsigned. Long suck. They're 4 or 8 bytes. They're not, and why? Well, because if you're on a 32-bit architecture with 32-bit pointers, your long will be 4 bytes. If you're on a 64-bit architecture with 64-bit pointers, your long will be 8 bytes. So it does make writing code easier if you want to make it flexible to whether it's a 32-bit machine or a 64-bit machine. But there are some times where I just like to have a 64-bit in it, you know? And you can do that. That's one of the ones I don't include. There is a uint 64T that you have to do a special include file. That gives you 64 bits. So you can actually get it, right? But as long as either 4 bytes. Then you got a float. How many bytes to float? 4. How quickly do you get round off error when you have a float? Like all the time. Floats are, I won't say they're worthless, but they're pretty worthless. I don't ever use a float because it just doesn't have enough precision. Floats actually have seen increased usage of late. Anyone want to tell me how that is?
Find safe space in ChatGPT, like whatever you do with inference.
Oh, you're getting closer to what I was going for. I didn't hear what you said.
Deep learning.
Yes, it's machine learning. Because with machine learning and GPUs, they've actually found that it can still be effective at that lower precision, and you could do a whole bunch more work with the smaller data size. So they'll even use 2-byte floats in some things, or variable size floats. And if that's not an indictment of machine learning, what else is, right? Just stay away. I'm joking, by the way. You don't stay away from machine learning. Machine learning is crazy. Anyway, double. That's what I use. All right, double's an 8-byte, 64-bit floating point quantity. Much more useful because you don't get round off error nearly as much. Although I did learn recently, you cannot represent the number 0.1 in floating point, in IEEE floating point. Fun fact. Okay, and then a pointer. Now, a pointer is also going to be 4 or 8 bytes. And your pointer is a first-class data type. Okay? Even though it's weird, you don't declare, hey, pointer, you always have to declare pointing to something, right? But your pointer is a data type that consumes that amount of space, just like an int is a data type that consumes 4 bytes. A pointer is going to be consuming some other number of bytes. What time we got? We got that. All right. Okay. Let's get rid of that. All right. Got some code. Not a very exciting code, but there are 3 places where you can declare a variable which is going to take some memory. Okay? There's number 1, global variable. If you put that in your program, you now have global variable. That's 4 bytes. It's sitting there in your executable until the end of time, right? Or until the executable goes away. But that's where it is. Now, we get told not to use global variables because it's bad programming, and that is correct. You shouldn't use global variables. It is bad programming. Okay? But you can. It's right there. Sometimes you can't get away with it. There are procedure parameters. Okay? These also consume space, right? This one's going to consume 4 bytes, and then this one's going to consume either 4 or 8, depending on how big the pointers are on your machine. Okay? When do they get allocated? They get allocated when the procedure gets called. Okay, so when the procedure gets called, and we'll go through this in great detail, when it gets called, there's a data structure called the stack, which is in your runtime system, and every time you make a procedure call, it allocates all of its variables on the stack. And then when you return, gives it back. Okay? So that's where this stuff is allocated. And then we have here, which is a local variable. Right, and the local variable, that also consumes 4 bytes, and it consumes it on the stack. When does that get allocated? When the procedure starts. Okay. So this gets allocated when the executable gets loaded. This gets allocated when main gets called, and then main gets called by its caller, and then this one gets allocated when main starts running. Okay. And then when main stops running, it gives it back, and then when main stops running and it goes back to its caller, that gets given back. Okay. And again, we'll go over all of that in detail. If you want to know, and all these here, I know it seems crazy to be going over an assignment statement in like a 6th semester computer science class. Sorry. But it's just good to know. These are copying operations. All these are copying operations. I'm going to take these 4 bytes and I'm going to copy them to those 4 bytes. That's what's going on right there. Right? Same thing. These 4 bytes. And I crack on Python, right? Because Python, often you have no idea what this does, right? I mean, C++ too. There are times when if I take an instance of a class and I assign it to another one, Lord knows what's going on under the hood. Might be doing a whole bunch of memory allocations and copies and deallocations. It's one of the nice things in C. In C, you know what's going on. I'm copying these bytes to those bytes, period. Okay. All right, go ahead and print it out. Size of, you give size of a type, right? Like long, it'll return how many bytes are in that type. That's nice because long, you actually don't know how big long is going to be until you run it on a machine. Okay? If I say size of int star, that's telling me how big the pointer is. That's not telling me how big what it points to is. It's how big is the pointer. Again, 4 or 8 bytes, and it should match, right? These two should match. So when I run this, look at that. Doesn't it just make you happy when you don't see compiler warnings? Makes me happy. P1. All right, so my Mac has 8-byte pointers. If I ran this on my Pi 3, do Pi 4s have 64-bit? I think they do. Yeah, so Pi 3. Can anyone even get a Pi 3? I have about 10 of them. I still use them. But on a Pi 3, then this would be, that would print 1, and then this would print 8 and 8. And you'll note I'm printing argc. May as well get this one out of the way because I'm hoping you all know it already. argc, that's the number of words on the command line when you execute the program. Okay? So when I say bin/p1, argc is 1 because I have one word. This is my one word of the command line. All right? If I say bin p1 a b c d e f g, okay? Now it prints out it because there are 8 words in the command line. But it's not, this one doesn't get ignored. This one's part of it, right? So it's 8 including that. And I just reiterate this because if you're not used to it, it confuses you. And you forget, argv0 is going to be bin/p1 here. And argv1 is going to be a. Okay? All right. Aggregate types. All right, there are 2, here, I'll put it up here. There are 2 aggregate types in C. And I know there are more, but I'm not going to tell you about the other ones because they're Byzantine. Okay? So, one is an array. And the other one is a struct. Now, these have kind of analogs in C++, but the ones in C++ are vastly different. I mean, I know C++ has C-style arrays, but when you're using an array in C, you would be using a vector in C++. And vectors are nice because they're these heavyweight things that, A, manage the memory for you. That's the great thing about a vector, is that I can keep calling pushback, and it'll keep pushing back into a little memory buffer, and then when that buffer becomes too small, it's going to allocate a new one, copy everything over, and you don't see any of that. You just use it, and it works nicely. Okay? That's how a vector works in C++. In C, the way an array works is you can, we'll talk about a couple ways of declaring an array. But what I'm saying here is S1 is an array of 15 chars. Okay? Now what's going to happen, this is a global variable. Okay? So when my program starts running, there are going to be 15 bytes allocated for this array. And then when I use S1 in my program, what it's going to do is it's going to turn that into a pointer to the first of those bytes. Much different from C++. Okay? And a large source of confusion for students. Okay? Because I told you, how big is a pointer? 4 or 8 bytes. How big is this array? 15 bytes. Well, what about the pointer? There is no pointer. But if I use it, then it'll give me a pointer. That's correct. When you use it, the compiler will generate the pointer for you. but the pointer isn't sitting there in 4 or 8 bytes being stored anywhere. Okay? It's just this is 15 bytes, and then when I use it, which I don't here, when I use it, then it will point to the first of those. Okay? And then they're contiguous in memory. Always contiguous in memory. Okay. Here's another one. Right? Now this one's just 4 bytes. Okay. Here, if it were a C++ string, I would be allowed to do this. This is illegal in C. In C, you can't say my array equals something else. Right? Because really, this isn't a pointer. This isn't a pointer. It's weird. This is just those 4 bytes. But you can't just assign it. This, in fact, is another pointer. Okay? It's a pointer to 4 bytes, typically allocated up at the top of your executable that have already stored in them from the compiler JIM and the null character. Okay? So if I try to do this, it's going to fail. My compiler will yell at me. So here, let's do it. Let's have the compiler yell at us. Yep, because it didn't like that. So how do I do it? Ugh. That's how you do it. There's a primitive called strcopy that allows you to copy a null terminated string in the second argument into the first. And we'll go over this in detail as well because it is fraught with bugs. And it's fraught with bugs because of what I've told you before. In C, you got to manage all your memory. And if you don't manage your memory correctly, you got problems. Okay. Let's look at another piece of code. Sorry. P2. No, that's not right. Yes, that is it. All right. Now, we got a main, it's got an int, we got this. How many bytes? I'll get to you. How many bytes? For both of these. It's 24. 20 for S. Remember this whole pointing thing, it doesn't matter. And then 4 for I.
In the previous example, you used 4 bytes to store gems of the new line character.
Yeah, it is. And I'll talk more about that because that's confusing. I'm doing it here too. So in C, strings are revolting in C. In C, your string is a pointer to a char star, and anything that it uses a string or interprets a string is just going to assume that your string exists from there until you hit the null character. That is a C-style string. All right? No nice heavyweight stuff like in C++ where it keeps track of the size for you. In C, you give it this pointer, it assumes that it's going to be a legal string that's null terminated, and if it's not, then God love you, right? Because your program's not going to work, and it's not going to work in an ugly way. Okay, so what I do here is I do, and so things like printf, that's exactly what they do. When I say printf %s, right here, that says this is going to be a pointer to a char, and I am going to print out every character until I hit the null character, at which point the string's done. Does printf know how big the string is? Just going to start printing. Right? So that's what's going on here. I have 20 chars. I set the first 19 of them to characters, and then the last one to the null character. So now I have a legal C-style string. If you haven't seen this before, the character A, when it gets put this in your compile, is turned into a number. 97. I would like to say I didn't know that, but I do. It is 97. And then so B is going to be 98, and C is going to be 99, et cetera, et cetera. Oops, 97. Okay, and that's how you can do things like set this string from A to whatever that would be. Well, to this, A up to S. Okay. And I print it. It's going to print that. Now, when I call a procedure using S as an argument, okay, it's going to pass the pointer. It's not going to pass the array. In C++, if we passed a vector, it makes a copy of the vector, right? Unless we have it be a reference parameter. There are no reference parameters in C. Okay? Everything is copied, which means the pointer is copied, not the array, but the pointer. Okay? So if I go up here and I want to change case, right? So what am I doing here? I start at the first character, I go until I hit the null character, right? And then I check and I see, all right, well, if it's a lowercase letter, then I'm going to turn it to its uppercase equivalent. Okay? And because it only copied the pointer and it didn't copy the memory, now when I print it out here, the case will be changed because it changed those bytes. Right? Again, in C++, if that were a vector, it wouldn't change them because it would copy the vector, change them, and then throw away the copy. Okay? So there, it changed it. Now, the other thing is, although I put this A20 here, it's like a placebo. The compiler doesn't give two shits about that 20. In fact, the compiler throws that 20 away. So I could say A0. Maybe not. Let's say 1. We'll try 0 after that. It'll compile. It'll run. Right? Let's put a 0. Let's see if the 0 works. 0. Yep, compiles, runs. So I said it's a placebo. You can do that. That makes more sense. It's an array. I don't know how big it is. No one knows how big it is. It's C. We don't know how big it is. Okay? So, but I can run it. And I can do this. Because it is a pointer. And now you can take a pointer and treat it like an array. Because it'll say, all right, well, this is the beginning of a contiguous memory. Let's just keep going, right? So A sub 1 is going to be 1 char after A. So this works as well. So for this reason, usually when I'm doing it, I'll do this. Because what's inside makes no sense. And I think that's just confusing. So I'll do that, or maybe I'll do that. Or sorry. I kind of like this better, but personal tastes do vary, so you can do what you want. Now, getting ahead of myself just slightly, but just because I was thinking about it. I can add 1 to this pointer, and now it's pointing to the second element. Okay? Up here, this one doesn't care. It's just getting a pointer to the first byte. So if I do this, right, what's it going to do? It's going to change every character except for the A. The little case A is going to stay the same because when I passed it a pointer to that one, right? And this is why C is a horrible language, right? Because I can say, 400. I have no idea what's at that memory, right? Boom. I bet it runs. Yeah, runs fine. I just corrupted who knows how many bytes of random memory in there. But since I never read them, it never gave me a problem. This is why C is a difficult language. Yes, sir?
If you want to access the second element in an array of integers, would that be s plus 1 or s plus 4?
We're jumping ahead. But it'll be s plus 1. But we'll get there. The point arithmetic I'll go over more explicitly. But it's a good question that you're asking. Yes.
You put a negative 1 in the char A parameter?
Up here?
Yeah. You put a negative 1 in there?
I don't know. Let's find out. No! God! How dare you! The 0 makes sense. Good question. Fun. I bet that works differently on every machine. The Raspberry Pi has the most lenient, silent compiler in the world. Like the Raspberry Pi thinks you know what you're doing at all times, so it just doesn't give you any warnings. But my Mac is pretty chatty, which isn't a bad thing. All right. Structs. All right. Whoops. Okay. A struct is very similar to C++. It has some fundamental differences, but with a struct, it allows you to aggregate types together. So that I could say, for example, here I'll say struct. I'll give it a name. Should I give it a name? Yeah, I'll give it a name. struct, I'll call it ID for int double, and I'll say int I double D. Okay. Now, difference between C and C++. In C++, I would use ID as a data type. In C, you gotta say struct ID to use that as a data type. So down here now, I can say struct ID X. And now I can use these fields. So xi equals 5, xd equals 3.14, printf d, lg, x.I, x.d, return 0. Works all nice. So, you know, I could have two screens, couldn't I? That's where you can tell I haven't taught in a month and a half. Did you all forget all of computer science over winter break? Do you all not program every day of your life? I program every day of my life. It's a sad day if I can't program. So I'll just make up reasons to program. But that's me. All right, there we go. So we got this one here, make. Is that the right one? Doesn't feel like the right one. No. Okay, that worked. LG, do we all know what LG is? If you want to print out a double, you can print out with %LF. It's always going to put 6 decimal spaces on it. If you can put field widths on that to limit it, but if you do LG, it's kind of like what cout does. It prints it out in what it thinks is going to be the simplest way for you to look at it. It's convenient for when you're writing quick and dirty code. It's actually not useful if you're writing big code, because it'll automatically shove stuff into scientific notation, and sometimes that's not what you want. But it's just something to know, because it's nice. LG. Okay. One of the big surprises of my life. Does that feel legal? Or does that feel illegal? Right? With an array, I can't do this. I cannot set one array to another one. The compiler will yell at me. So, to me, it would be logical to think that this would be illegal because you can't take one aggregate type and set it to another. Guess what? It's legal. Not only that, it copies everything. I was shocked. I'd been programming in C for probably 16, 17 years before I discovered this, because I just didn't think it was possible. I thought everything in C you did on nice little 4 and 8 byte chunks. But this is one part of the language. I actually think it's a weakness of the language, where you can do anything. So I could do, for example, I could say int x 4000. Right? So now my struct is 16,000 bytes. Right? And if I did do that, that is copying 16,000 bytes in one line of C. I found that shocking, because it just doesn't seem to conform with the philosophy of C. But there it is. Now you know, for good or for bad, right? You might view this as good. You might view it as bad. It also means that if I have this inside a parameter, so here, void A, struct ID, B, right? That copy is 16,000 bytes. Right, because, oh, and I got to call it. I didn't call it, did I? Sorry. Right, AX. That statement is going to copy 16,000 bytes. And then when it's done, it's going to throw those 16,000 bytes away. So it's just good to know about, because normally in C, you don't get hit with those surprises. How am I doing? Oh, I'm not doing too bad. Okay, in C++, okay, so now let's think about a struct. Think about a struct in C++, right? In fact, I'll put it out to the class. what are the differences between a struct in C++ and a struct that I've just told you in C? This is it in C, right? That's a struct, period. Okay. Now, what can you do in C++ with a struct that you can't do in C?
Member functions.
Methods? Yep. Member functions. Same thing. Member functions.
You said public and private.
Yep. Public and private. Can you put a constructor on it? Maybe not. I don't know how to use them. In C++.
Yeah,
You put a constructor on a struct? There you go. Put a constructor on a struct. What else do we got? Oh, assignment overloading. All right. You got all that stuff that you can do with a struct. So a struct in C++ is plus in C++, it defines a type name. All right. If I say struct ID in C++, now ID is a type name. Whereas if I say struct ID in C, it's not. I have to say struct ID. Now in C, you can and should use the type def. You can say type def that ID. Now I can use it as its own type name. And you can do that with any type. You can rename int to Fred if you want. It doesn't help your code readability. Okay. So, very different. And this is why now, maybe if you don't ever program in both languages, but I program in both languages all the time. I'm primarily C++, but I do program in C. I don't ever use a struct in C++. I just don't. Never. I use a class. And the reason I do that is because it helps me think about keeping my code portable, and I'm not doing illegal things in C that I couldn't be doing in C++. Slightly vice versa, but not as much. Now, that has gotten students in trouble when they adopt my philosophy. Okay? So what I'm telling you now is you do not have to adopt my philosophy. You can use structs in C++ as you see fit, and then you can manage the mental difference between what's a struct in C++ and what's in C. Now, one of the funny things is I had a student who never used structs in C++ because they blindly followed the lead of their professor, and then they got in trouble in a job interview. And the person in the job interview said, "Why are you using a class? Why aren't you just using a struct?" And the student's like, because Dr. Plank told me to. Proper answer to that question, if you have it, is I'm programming in C and I'm programming in C++, and I want to make sure that I'm bug free. So I only use structs in C and I use classes in C++. At which point your interviewer will say, "But aren't structs more efficient than classes in C++?" And then you answer, "Not if your compiler writer has a brain in his head." And then your interviewer will go, "Next question," and you're good. Okay? So now that you've got all those things, we're done. We're at a good stopping point. Sorry, no clicker questions or anything. We'll start those up. So have your accounts. Will I open the first lab? I don't know. We'll see. I'll get there.